Hi guys, let's take a look at this question. Weather balloons are sent into space to gather data. The balloons usually burst at a pressure of 27,640 and a volume of 36,3. The data collected then falls back to the Earth. And there we have this diagram here. The gas in a certain weather balloon has an initial volume of 12,6 and a pressure of 105,000 at a temperature of 25 degrees Celsius. Remember, we don't want Celsius, so immediately already change that to Kelvin. So we're just going to add 273, and that will give you 298 Kelvin. Okay, 5.1. Calculate the temperature of the gas in Celsius in the balloon when it bursts. Okay. So we have the pressure when it bursts, and we have the pressure initially. We have the volume when it bursts, and we have the initial volume, but we only have the temperature, we only have the initial temperature. Okay, so they want the temperature when it bursts. So we can comfortably then use this formula because the only one unknown will be T2. So I'm going to jot down my formula here because I want a mark for my formula. I get a mark, so this is free marks, guys. Free marks to just jot down a formula on your answer sheet. Okay, so this is going to be my initial pressure, which is 105,000. And my initial volume is 12,6 meters cubed. So 12,6. My initial temperature is 25 that I've converted to Kelvin, which is 298. The pressure when it bursts is 27,640. And the volume when it bursts is 36,3. And they want the temperature when it bursts. So I do my math magic, I multiply, divide, etc. What I must do to get the temperature alone, and the temperature in Celsius, or in Kelvin first because you've converted that. So in Kelvin it will be 226 Kelvin, but then you just minus the 273 again to get negative 47 degrees Celsius. Okay. What is the initial amount of gas in moles in the balloon? So essentially they just want the number of moles, right? So we have pressure, we have volume, we have temperature. So we can use this formula to get our N. And remember, R, the molar gas constant, is right there. Okay, so I'm going to jot down my formula because I want marks. I don't know if you don't want marks, but I want marks, so I'm writing down my formula. Okay, they want initial gas. So the initial pressure was 105,000. The initial volume was 12,6. They want the number of the amount of gas in moles, so the number of moles. I just said my R is my constant, which is 8,31. And we've just calculated the initial temperature to be, and remember, the initial temperature is 25 degrees Celsius. We've calculated there as 298, so 298. And I multiply, divide to get N by itself. And then initial amount of gas in moles in the balloon is 534,25 mole. And that's it. Easy peasy. See you in the next one.